Hello, boys and girls. Today we are going to learn about mole ratios. So what is a mole ratio?
It's the ratio of the moles.
Okay, ratio of moles. So let's start by balancing an equation. That's the first thing you're always going to have to do is balance your equation, or else you won't know the relationship of the moles.
And if you don't know how to balance equations, or you don't remember how to balance them from last unit or from the previous unit, just make sure you go back to that video and figure it out. Very important skill to have.
Okay, so let's quickly balance this. I see 3 iron in my product, so I make 3 iron in my reactants. I see 4 oxygen, so I'll put a 4 here. I have 8 hydrogen, so I put a 4 here. And now I'm balanced. Does that look okay to you?
Yep, and hopefully you're just as expert at balancing as Ms. Engarasi is.
Hopefully. Okay, so you can see by looking at this that in the balanced equation, 3 moles of iron will always react with 4 moles of water, H2O.
Okay.
That's the ratio of the iron to the water, so 3 to 4. And will always give you 1 mole of your Fe3O4 and 4 moles of H2. So those ratios are set. Once your equation's balanced, those are the set ratios.
So the coefficients tell us how many moles of everything there are.
Yes.
Great.
So let's look at it this way. If I start with 10 moles of iron, and I want to know how many moles of water I need to use up all of the iron, you would write it like this. 10 moles of iron. Okay, and now we're going to set up a train track again.
Ah, those train tracks. Back again.
So I want to know how many moles of water I would need. I'm solving for water, so water stays on the top.
Okay, moles of water up on the top.
So 4 moles of H2O, I'm going to run out of space. And 3 moles of iron, because for every 3 moles of iron, I need 4 moles of water.
And you just got that from the coefficients of the balanced equation.
Yep. So
Great.
moles of iron cancels. 10 multiplied by 4 divided by 3 gives me 13.3 moles of water. So in order to use up all of the iron, I would have to have 13.3 moles of water.
If I have 10 moles of iron and I want to use all of it, I need 13.3 moles of water. Sorry, I just have to repeat it. Great. Well, can I compare the iron to the products?
Yeah, so
also?
let's do that. I'm slow at erasing.
Don't worry, we'll fix it in post.
Okay, so same thing. If I have 10 moles of iron and I want to know how much of my Fe3O4 to 3 moles of iron, just like that.
So that's just a 1 to 3 ratio.
Yep.
So for every 3 moles of iron, you get 1 mole of Fe3O4.
Mm-hmm.
What you want goes on the top.
Oh, I left off moles. That's okay.
That's okay. Forgot to put moles, but yeah, you guys know it's supposed to be moles.
So 10 times 1 divided by 3 is 3.33 moles of Fe3O4. So if I start with 10 moles and I have enough water, then I will end up with 3.33 moles of the Fe3O4.
Okay.
And let me see if I can squeeze this on the bottom. So again, if I start with 10 moles of iron, how much hydrogen gas would be released? I would have 4 moles of H2.
So hydrogen, because it's what you want.
3 moles
okay.
of Fe.
Iron's what you're trying to get rid of. Okay.
Yep, so then again, these cancel. 10 times 4 divided by 3, which looks just like the water, will be 13.3 moles of H2.
Right, just recapping here, so the coefficients set up what ratio these guys react and produce with each other, and that can kind of give you a hint with any number of moles. So you picked 10 moles of iron just because you were saying, what if I had 10 moles of iron?
Right.
How much water would I need for the reaction to take place, and how much iron, how much Fe3O4 and H2 that would produce?
Right.
Awesome. Awesome. Well, that seems great. Your inspirational message for this video is, it is better to be truthful and good than to not. See you next time.